Hi, in this video, we're going to have a look at the null factor law, which will allow us to solve quadratic equations, acknowledging that all quadratic equations can be written in this format, x minus a, x minus b. Of course, it could be plus and plus here, but it doesn't really matter so much. So just to point out what I mean, if I use the chicken beak method and expand this, I'm going to get x times x, which is x squared, x times minus b is minus bx, a times x is minus ax, and minus a times minus b is minus ab. And if you want to be really fancy, you could then say that's equal to x squared minus, think about why this works, you can pause and work it out for yourself, but minus a plus b, and then you've got minus ab at the end. So it's definitely a quadratic. This operates like the coefficient of x, and this is the constant term here. Now, for an equation, we have to set it equal to 0 in this instance. So this is what the null factor law says. It says that if I have two factors set equal to 0, then the only way this can be true is if the first factor is equal to 0 or the second factor is equal to 0. Okay, now this works for any possible numbers. If I go just a times b equals 0, that can only be true if a is 0, b is 0, or both of them are 0. If I said to you a times 3 is equal to 0, then a must be 0 because the other number is 3, and that's the only possible solution there. So that's what we're talking about. If I then work this through to possible solutions, it means that x equals a is a solution of the quadratic equation, or x equals b. So what does it mean in practice? It means that if I can take a quadratic and factorize it into its two factors and set it equal to 0, then each factor becomes a possible solution for the quadratic. Let's have a look at it in practice. I've got two examples here. Down at slide 3, we'll have a look at example 1. I've got x squared plus 6x equals 0. This is a quadratic because there is a constant term, there is a value of c. What is it? Pause the video, maybe think about it, and then start it up again. You can see that if I had to, I could write in a plus 0 at the end, so the c value is 0. So it is a quadratic even though the c value is not there. I can factorize this, x outside of x plus 6. That's a fairly straightforward factorization at this stage. And now I can say, and I tend to write this myself by null factor law, x equals 0. And you can go straight to x equals negative 6 if you want to. Or you can just go x plus 6 equals 0 and then solve to x equals negative 6. But whatever makes you feel comfortable, as long as you're getting them consistently correct. Okay, so that's that problem done. We simply take each of the individual factors and we set them equal to 0 and solve for x. And if I take this value here, for example, x equals negative 6, and substitute it in, I do get it. Negative 6 squared is 36 because a negative times a negative is positive, so that's 36. 6 times negative 6 is negative 36. So we've got 36 minus 36 equals 0. So that works, that's a check. Looking at example 2, x squared minus x equals 6. Now you might be tempted to factorize to start with, but that would be a poor place to start. We do need to have the equation set equal to 0 before we can use the null factor law. So the first thing I'm going to do is I'm going to subtract 6 from both sides. That'll give me x squared minus x minus 6 is equal to 0. Then you can use whatever method that you want to in order to work out what the factor pairs are. I know that I need x squared here, I know that I need negative 6 here, and I know that I need to get negative 1 in the middle, or negative 1x to be precise. So x times x here, and now it's just a matter of choosing factor pairs that will give me negative 6. I'll go straight to the right pair right now. You might need to do a few different tries of it until you get it right, so don't think this is anything other than me shortcutting the video. So we've got negative 3 times x, which gives me negative 3x, and I've got 2 times x, which is equal to positive 2x, and negative 3x plus 2x does give me the negative 1x here. So I've now used my factorization technique, just the box method in this instance of a trinomial, to get the two factors x plus 2 multiplied by x minus 3 is equal to 0. And now that I've done that, I can set each of the factors equal to 0 and solve it. So by the null factor law, x plus 2 equals 0, which gives me x equals negative 2. Notice how I'm using an arrow there to describe what I'm doing. And x minus 3 equals 0 gives me x equal to 3. And so they are the two solutions to the problem. And again, we can take any of them. I'll choose x equals 3. And you can see that if I've substituted into the original equation, we've got 3 squared equals 9, minus 3, 9 minus 3 is equal to 6. So it is a solution for the equation. Okay, I'll leave this video here. Next video will be on using completing the square.